My name is Nakul, and if you haven't figured out where I'm from, let me help you. I'm from India, and as you know, in India, we have tradition of stories, or shall I say a lot of stories. So being an Indian, I thought what could be the best way to start DevOps than a story. So let me share with you a story which my mother told me when I was a 6-year-old kid. And this story made a profound impact in my professional career. It was a story about a group of blind men. Those men heard that there is a strange creature called an elephant, which is brought in the kingdom. But none of them were aware of the shape and form of the elephant. Actually, they have never seen an elephant before. So they thought, all right, we are curious enough. We will like to know a bit more about this creature. So they went to the king and said, oh, dear king, we will like to know about elephant, and we will like to, see what an elephant is. But since we are blind, we will like to learn about this creature by touching him. So the king said, all right, we can make the necessary arrangements. And next day in the morning, they made all the arrangements, and one by one, each and every person started touching an elephant. The person who touched the trunk of an elephant, he said, well, this thing is like a snake, a thick snake. Other ones say, well, I'm afraid an elephant is a wall. The third guy say, well, you both are wrong, it's a rope, it's a big rope. So on and so forth, each and every one of them started giving their own version of what an elephant is. The last person said, an elephant is something which is smooth, which is hard, and it's like a spear. It took me a while to realize in my professional career that I was the same blind man. Because the code which I was developing, which I was calling a domain model, was nothing but a technical soup, and a lousy one, mind you. I was developing classes which have a bunch of attributes, getter, setter, annotations, and more annotations to make sure how the object can be saved properly to the database. I always say to my friend that code is like water. It reflects your dedication, your hard work, how much serious you were when you were developing it. However, in my case, although I have the best intentions, my code was not reflecting what business wanted. It was reflecting more my perception blurred with the technical vision. And the reality of business was something entirely opposite. Fortunately, one day I came across this book called Domain-Driven Design. And when I finished reading this book, it changed the way how I operate and approach software architecture. This book told me to change my focus from technology to domain. And if I have to summarize DDD in 4 points, how I started applying it was, first thing I did is I started placing behavior in the domain model. I make sure that my code will reflect the reality of the business. So I started working with the business people to understand what is the reality of business from the eyes of business. And we started developing a common vocabulary, which we can use throughout the organization, all the way to my code. I started using aggregates to provide unit of consistency across my domain model. And finally, I needed to define my bounded context. I needed to protect my domain model because a customer for a finance department was entirely different than what player marketing would imagine. And both of those definitions have to exist in the same code base. So I needed to work on my bounded contexts. I mentioned on just the previous slide about aggregate. So if I have to define what an aggregate is in one sentence, I would say they are a group of objects or entities that naturally belong together. And they can provide the consistency unit across the domain model. So you can update and delete things and changes at the same time. That's all what I have to say about DDD. Now I would like to discuss about an architecture pattern in which events are considered as the source of truth. And basing on those events, some components can rebuild their own state. At least that is what most of the people agrees. Remember the story of the blind man, which I told you. There is one important detail about event sourcing. And in event sourcing, it's not about just publishing events. The component which publishes the event is the same component who will consume the events. So put it this way, the component have no other state except the events stored in the event store. Let me walk you through an example. So in a traditional app, let's say we want to order a burger. And at the end of the day, we will have something like this in our database, a row where we will have an order ID, the amount what we bought, the product which we bought, and maybe the order was shipped. We can have tons of more information, but at the end of the day, this is what we can have in a database row. Let's try to see how the same app looks from the point of view of event sourcing. So if we have built the same app using event sourcing, we can see what actually happened. So first thing what happened is the person added a veggie burger, then he decided to add a salad, then he decided to add an ice cream. Oh, and then wait, what happened? The person removed the ice cream, the person removed the salad, the order was confirmed, and finally order was shipped. As you can see from the point of view of my business, there is a whole series of events which took place in a blink of an eye. And if all this information would be accessible to the business people, they could react on it and tell us what is the best way to engage the customer. Maybe the reason why a customer decided to remove the item was maybe the delivery time was too much, or maybe the delivery cost was too high. Actually, all this information is a food for machine learning and big data. In real world, companies like Amazon went to so much extreme, and they are like utilizing this thing to such an extent that they will even ship a product before a customer have bought it. They are so good in predicting it. And not only for the groups, they can predict an individual behavior of a person. A natural question now which will pop in our mind is, where do we store all those events? And the answer is event store. An event store makes sure to store the events and make them available for the consumers as well as the publishers. The publishers are the components which publishes the events. The semantics of event store can do, there is not a lot of things an event store should do, but it should do three things which it should excel in. First, it should be able to append things fast. And since aggregates are the one which produce the events, it should also validate the sequence number when it is writing, because you don't want to get into conflicts if you are running application on two different boxes. And finally, which is very important, is that you want your event store to provide you the access for information as fast as possible, so you can replay all the events at a blink of an eye. There are a bunch of implementation available. One is by Event Store by Greg Young. Another one in 2018 is launched by Axon DB. You can also use relational database. No one is stopping you. However, remember, if you are going to do events sourcing at scale, relational database are not the best fit, speaking from experience, or you can roll out your own. The final part of the puzzle which I want to discuss now before diving into the demo is CQRS. So in a real world, the problem is that domains tends to be quite complex. They tend to evolve and end up being quite complex. And we need different models to address those problems, even in the same bounded context. And CQRS is a common way to do that separation. So in CQRS, we can divide things in command and queries. And in command part, we want to focus on nailing the domain logic. And in the query part, we want to nail the domain data. So what are commands? Well, when you want to do something in the system, you use a command. So for example, I want to send an email. I want to order something. These are the example of commands. Commands usually have a side effect. Queries, on the other hand side, are all about information, the desire for information. So when you want to have some information presented on the screen, you use the queries. So let's try to analyze how CQRS looks like from a UI perspective. So you can have the commands routing to one side of the system, which is command model. But in that part of the system, you want the people who have very intimate knowledge of domain to work there. On the other hand side, you can have projections or queries where you can afford to have people who don't have so intimate knowledge on the domain, and they can still work and contribute there. We can publish, obviously command model can publish some events, and they can be received by projections. However, rather than emitting an event and forgetting about it, we can start storing those events. And by this way, the command model can rely on those events as the source of truth. So when command model don't store any state anywhere else, it stores all the state in those events. I hope it rings a bell in your head, because this is something which we discussed in a couple of slides before. This is event sourcing. So we can combine CQRS and event sourcing to build highly scalable systems. It all sounds so easy, isn't it? However, the devil is in the details, or shall I say the technical details. When you are doing CQRS, you need to think about commands. You need to make sure that commands are routed properly, events are delivered in the correct order. You need to think about buffering of the events. If you implement a knife implementation of CQRS, let's say if you have multiple publishers or components which want to consume from the same source, you can end up doubling the I/O and also utilizing CPU twice as much, because you will deserialize. Also, you can have some race conditions, and I'm even not discussing here sync and async way to keep the thing simple. So at this point of time, you can either start to think about maybe, create that sort of a framework, and there is no problem, you can do that. However, you have to keep in mind that when you are developing this piece of code, you have to divert your attention from business problems to the software problems. Or maybe you can use a framework like Axon. I hate to name drop the frameworks in the conferences, but in our case, Axon helps to take care of all the non-functional requirements around CQRS and event sourcing, and let us focus on the meat of the problem, which is our own domain. This framework started to develop, I guess, sometime around 2009, and from that time, it is constantly being developed. And as of 2018, the guys behind Axon Framework have formed a company, and they launched 2 products. So Axon DB is a dedicated event store, and Axon Hub is a product which they offer for messaging. So if I have to say what Axon is in one sentence, I will say Axon is all about location transparency, and every other thing is just, other stuff out there. What location transparency means in this regards is that you have a component which calls another component, but this component is not interested to know what is the location of the other component. And this comes quite handy. So let's say if you have done DDD right, then you might start building a monolith, and as your needs grow, you can start extracting those services into their separate microservices. And location transparency plays a key role. We can implement location transparency using APIs, like using futures or using messaging patterns. So this is the best part of the talk, because this is where I'm going to show you the demo. So I have prepared a sample application. But first I would like to walk you through what the demo application is about, so we understand what the demo is all about, and then we will dive into the code to understand the bits. So the application is simple. It's about betting. Person can place a bet, and basing on the outcome, they can win some money and lose some money. And there should be no shock that I'm speaking about a demo with a betting app, because I work in a online gambling for an online gambling company. So the first thing which we need is we need to put some money into our wallet. So we need a digital wallet. So let's create one. So I can create for myself. Since we are in Poland, we can use Polish zlotys. I can click submit, and the moment I want to click the submit, what I want to do is I want to execute a command into my system which should create a wallet and maybe publish some events. Not maybe, it should publish, because we are going to see that I'm using EventSourcing as well. So the moment I click submit, it seems the command failed because Polish zlotys are not supported. So let's go with euro. Although Poland is in EU, but still we use Polish zlotys here. So let's go with euro. So as you can see, this time the command is validated. Let's try to deposit some money into our account. Let's put 50K. Again, I'm going to execute another command. And as you can see, the command is executed, and command published some event. The event was picked by a projection, and the UI is updated there. We can use multiple projections, can use and listen for the same event. So let me show you what I mean. In order to demonstrate it, I created a management UI. Okay, let's try to squeeze this thing in. So right now, as you can see in my wallet, I have like 50K money. Here you can see. The moment I'm going to deposit a bit more, 3 projections should be updated. This, and this. Please note they all are individual projections. So I'm putting 50K. And as you can see, this projection also was listening for the deposit event. It get updated. This one get updated. And this one get updated. And there is no restriction on how many projections we should have. We can have as many as we want and as much our business demands for. So finally, I can start placing some bets. So since football is going on, let's place a bet on France. The moment I want to place a bet, few things should happen in the system. First, the money which I'm betting should be frozen, so I shouldn't have access to this money until unless the bet have a outcome. It can be positive or negative. And also my balance should be updated. So let's see, when we submit a bet, as you can see, my money is frozen, some funds, and I have available balance of 75. Let me show you again. Germany, let's put 25K. So as you can see, some amount of my money is blocked, and my available balance is 50K. And basing on the outcome, this money should disappear from my account or it should double. However, I'm not liking this outcome because I'm losing like 50K in just 2 spins. So let's try on Brazil to bet. And as you can see, these projections are also updated. The outcome of the bet is again lost. Damn, I'm losing. I'm on a losing streak. Let's try Poland. Since we are in Poland, maybe threads will give me some mercy. So this is my final spin. All right. There is someone upside who listens. So as you can see, my money, which was frozen, ended up being double. And as you can see, the projection also were updated. I can also create another wallet. So for players, I can say for, I don't know, Adam, and I can choose USD. And you can see I have another player here listed, and I can say maybe put, I don't know, 50 grand. And as you can see, that projection is updated. So this is the first part of the demo. Let's dive into the code now. So we started this demo with some commands. So let's take a look on wallet here. So as you can see, commands are nothing but a simple POJOs. In my case, I'm using Kotlin because it is concise and I like it just for the sake of readability, but you can use Java, and we can have a bunch of fields here. In my case, I kept it to the bare minimum, which is wallet ID and currency. When a command is executed, it needs to target an aggregate. How do we make this connection? Well, we can use @target aggregate identifier, and Axon takes care of the rest. It makes sure that the command will be routed and targeted to this particular aggregate. In the similar manner, you can see I have a bunch of commands like deposit, request, but as you can see, they all are just simple POJO, nothing fancy, except this @target aggregate identifier. So let's try to see what an aggregate looks like. So the first thing you need to convert to a class to an aggregate is annotated with @aggregate annotation, and it tells Spring and Axon that this class is an aggregate. I will show you how Spring auto configuration kicks in. And an aggregate should have an identifier. We can choose here foo, bar, whatever as an identifier, but please make sure the name of the identifier should match the one which you use in the command. So if you call here this thing foo, for example, then that thing should also be called as foo. That's what the target aggregate identifier does. You can see there are a bunch of fields in this class. They are not here because we want to map this thing to a database. They are here because they make sense from the point of view of business. So in aggregate, you don't just bluntly start adding fields. You just add the fields which make sense from the business. So put it like this. If I don't need to validate currencies, I should not have this field in the class. I should not think about database or something. Then we can start handling the commands. As you can see, I am doing some validation. That's why the Polish zlotys was not supported. And basing on the validation, I throw an exception. Here I'm throwing illegal argument exception, but in journal it's good to throw a business-specific exception. But this is a demo, so I didn't want to complicate it more. And once the validation is successful, I fire an event which is called wallet created event. The name is in past because this is the convention. You want to name your events. Events should be immutable, and they should depict something which have already happened. As you can see, the event is nothing but a simple POJO. Again, you can use Java if you want to. And in the similar manner, I have a bunch of other events which have a bunch of fields here. So in a normal Java class, what we will do at this point is we will do something like this in the constructor. We will say command.walletID, for example. This is what we are used to do in Java, normal. But please note that we are using event sourcing here, which means that all the state change should happen when the event is applied. So in an event sourcing handler. So in my class, I will have something like wallet created event. I am handling this event. I'm initializing the wallet ID, giving it a currency, and setting the balance to 0. In the similar manner, when I'm depositing here, for example, you can see I perform some validation, issue or emit an event, and the event is handled, and I update the available balance. As you can see, the code is really, really simple. Although a lot is happening here, but it is simple in the sense of I'm not doing some magic here, I'm just updating some field. The final thing I want to show you, and then we will move on the projection, is this constructor. Why this thing exists here? So behind the scene, what happens is you have an aggregate. Aggregate is not loaded in the memory yet. So first time when you access an aggregate, Axon need to load this aggregate, load the definition of this class, and all the events starting from the beginning till now gonna be replayed. Obviously you can have snapshots, so then you don't go like 10 years before and the replay become endless. But that's why we need this empty constructor. So Axon is going to kick in, create the instance of aggregate, and apply all the events. So this is all about command handling. Let's dive a bit on projections. So I have here a wallet summary projection. A projection is, as you can see, there is nothing fancy. There are no annotation that this thing is projection except the name. I can create some method, and the important part is the parameters. So this method accepts wallet created event. And then I can annotate it with @EventHandler. And Axon makes sure that the events are delivered in the correct way. Here I am using Entity Manager. I'm using H2 database in memory because we are all aware of relational database. However, you can use Cassandra, Mongo, whatever. And even you can publish more events from your projection. So here I have a wallet summary event which have a bunch of fields. And those events are listened by classes like player UI. So what player UI does is when a wallet summary events got emitted, it tried to update something on the UI. And for management, well, I have a management UI. And the same thing here. When the wallet summary is created, I try to update some charts and things on the UI. The last thing I want to say is about auto configuration. So we have Axon configuration. Axon auto configuration. This is the class I wanted to open. So as you can see, there is an auto configuration. So if you are using Spring, all those things like event bus, command bus, they can be plumbed together using auto configuration. So you just drop the jar in the class path, and if you have Spring, these things get kicked in, and you can start coding directly. There is auto configuration for many things. So let me show you on the framework. So those event bus and command bus, they are not like an enterprise ESB buses. You can use particular implementation. Maybe you want to use Rabbit, or recently I added in the framework support for Kafka. So what you can do is you can just drop in the Axon Kafka library or whatever in the class path. This auto configuration will kick in, and it will try to set some sensible defaults for you. And you can override them like you override in Spring. Create a property file or YML file and just override the things. So till now in our demo, we have seen like commands, simple commands which execute, they emit some event, and projection get updated. However, in a real world, life is not so simple. Sometimes you need to coordinate between different bounded contexts. What I mean is, let me show you with a demo. So back to my demo here. Let's log in for Nakul. So when I want to withdraw some money from my account, the scenario is like this. I will request withdraw, then I invoke some other service, some third-party service, and it can give me thumbs up and say, hey, you are allowed to let this player withdraw the money, or it will give me thumbs down, which means that I should not allow this player to withdraw the money In our domain, it's called KYC, Know Your Customer, or and in order to show you this scenario, I created the withdraw functionality. I can click submit. The request is went to the external service. Obviously, I mock the service, and the withdraw is approved. However, the service is not necessarily need to reply instantly. It can take up to 72 hours for this service to reply. And even the outcome not always is going to be positive. So here I'm trying to request something which is way big amount, like 6,000 euro, and my withdrawal is denied. So the big question here in front of us is, how do we manage complex transaction management with this sort of architecture? Can we use ACID? I'm afraid ACID is not well suited for this sort of architecture because the transactions are long running. And imagine a transaction which is running for hours in a database. That's not going to make your DBA happy and your database as well. Or we can use BASE, which is basic availability, soft state, and eventual consistency. So this model is a different form of transaction, and we can use Sagas. They used to manage the base transactions. They can react on event. They can coordinate activities between different bounded contexts as well as between different aggregates. Saga typically live here in an event handler, and what Saga is basically an event handler which can maintain the state. That's it. And it's a long-running event handler. So just to show you how Saga looks like, I'm not going to go through all the details. So I have withdraw approval Saga. You have an annotation to make your class as Saga. You can start a Saga. And a Saga can end in various ways. So in my scenario, I was ending when I was getting validation OK. I was approving the withdraw command. And if it was ending in a negative path, unhappy path, I executed a new command, deny with command. I highly recommend you to clone the source code and play around with it to see what Sagas are. Since it's 2018 and we want to scale, because most of the companies have the requirement for scalability. So I took the time to prepare a demo here which can scale. Here it is. So the demo is deployed on Google Cloud. I can log in here. Or maybe let's create a wallet. I don't know, for Adam. Oops, I was too fast to deposit. Okay, there is a primary key. Let's say foo. Okay. Wait, I was on a wrong guess. My session was expired. Sorry for that. Let's try once again. Okay. The demo works like this here on the, but that was the front end part. But I will like to show you how it looks on, how we can see the commands and all those things. So here I have I am using Axon Hub. I can see how many wallet instances I have here up and running. And basing on those info, I can see how many instances I have here. I can also go, okay, I have problem with internet. Let me use my 3G or 4G here to show this thing. It was not something which I planned to do. Okay, let me try to connect. Okay. All right. So as you can see, the demo is up and running. I can, and maybe some of you can also interact with this IP here, 35, 195, 194, and 19. So you can play with it. I can submit here. It is for my buddy. As you can see, I have the same app running on the cloud. I have the management view. I deployed it on Google Cloud. Here I'm using Axon Hub. You can see how many services I have up and running here. So I can go to the overview, see. Can you guys see this in the back? Are you guys listening anything? Okay, that gives me confidence. So let's try to scale this. Let's say I want to scale my wallet, and I can scale it up to 8 instances, for example. Maybe I need to log in first. Let's log in. Okay, and let's scale. So right now I'm trying to scale one of my services to 8 replicas. And as you will see, the wallet instance are going to be scaled. In the meanwhile, yeah, so now I hope Kubernetes will kick in and start to scale. Oh, as you can see, the number of wallets are increasing live. So I'm scaling it live on the Google Cloud right now. And I can scale any service any number of times here. I can also see which commands are getting executed on which machine. So I have deployed it in one region, and the application is deployed on 3 different data centers. So I can see who is handling which command here. So that comes handy. I can look at the queries, how many queries have been executed against my system. I can also take a look on Axon DB. So here, for example, I can see all the events which are happening in the system. So let's try to find some event. Aggregate identifier equals Nakul, for example. And you can see I have all the history. So first I created a wallet, then I deposited money, I placed bet, I won, I placed again, I lost, I did some request, and the withdrawal was approved. So that is all about scaling. At this point, I will like to, the demo was fun. The internet disappeared for a while. It was not so fun for me. But the thing is, if you guys go home and you want to start doing, CQRS or event sourcing, the question is, how can you find commands, aggregates, bounded context, domain events, projections, policy, so on? I'm afraid Google cannot help you here. And as much you like Stack Overflow, it's also not going to answer you about your own bounded context and domain. So what is the answer then? And we should do event storming. And event storming is more about bringing people together with questions and answers. Event storming and brainstorming are 2 different things. Brainstorming is more about generating ideas. And in event storming, we don't generate ideas. We try to go deeper into our domain and try to share the knowledge of the domain against which we're going to build. In our company, I work for Casumo, so we do event storming. We just put some paper on the glass. We usually create this sort of a table. I didn't have a full picture here because of the size, but we usually put the stickies and say which sticky mean what. The people, we give them sticky notes, some marker. People can start placing the event starting from left all the way to the right as the timeline. The discussion evolves. Some of the ideas end up in bin, and this is the most beautiful picture from the full presentation, which I like, because this shows how much amount of work I could have spent in building a system and then throwing it out. And as the day progresses and as you come to know a bit more about your domain and dive deep, you can see that bounded context and aggregates and commands starts to fall naturally. So in this picture, the paper with the thick line here they fall naturally on the bounded context. The end result of event storming is a wall filled with lots and lots of stickies, but it contains all the valuable information. So you know about your commands, you know your aggregate, you know the external systems, you even know your domain events, you have a better understanding of your read models and projections in journal. You know also about policies. So policies is something, if you want to do some validation, you know which sort of validations make sense. And this brings me to the end of my talk. So let's recap. We should start to think about domain first and technology later. DDD is not about perfection. It's about domain designing. It's about making sure that you design your domain properly. CQRS and event sourcing goes hand in hand. Axon can help to put theory to practice. You can build your own framework. You don't have to use Axon if you want to. We can do a collective learning using event storming. And at the end of the day, the more we learn about our domain, the better we can connect dots. And as we know, DevOps is all about learning and connecting the dots. So thank you, and you can have your Q&A. Before you have QA, just sit here. I have to take a photo.
I can take a photo of you.
Yes, that will be awesome. Because this is the important part of the talk.
3, 2, 1. Okay, I hope I took a photo.
You cannot screw this up. Yeah, so are there any questions? Oh. Which thing?
I have a question because...
This? This? Ah, GitHub link. Okay. Here it is.
Okay, I have a question because what
Sure.
I found about working with events, it shades a bit of shades connection between the components. It gets cumbersome to navigate through the code. Do you have any solution for that?
Yes, that's a good question. So we also realized the same pain, and I open an issue for tracing in journal in the Axon Framework, so we can use something like Zipkin to understand how the events are flowing and have a bit better understanding.
I have a question about versioning of events. How do you version your commands, your events? How do you handle different versions running or replaying events of different versions?
So versioning is quite tricky with events. So one of the things which people do is they can create version 1, version 2, and you can use upcaster, so you can cast the event from version 1 to version 2. However, from my experience, upcasters are not very helpful when you have like billions of events. It takes time and you need to evolve. So what I usually try to do is, and I'm still working on that stuff, is make sure that you can make your events backward compatible and also put a lot of focus on event storming, because then when you are designing the events, you are working with your domain expert. So the chances to screw up, still exist, but the surface area is very, very small. And you can use something like Avro, for example. So you can have a schema linked with a particular event, and then you can evolve it. Or you can also, one of the other things you can do is you can just, if you don't need all that event, you can just, migrate from version 1 to version 2. So there are, depending on the context, you can use, there is some solutions available. Yes?
Does Axon have any support for unit or integration testing?
For what?
For a unit or integration testing?
Yes. So I didn't show the testing here, but you have the, they have the approach of given, when, then. So you can create an aggregate, and then you write test like this. Given, when this command is executed, expect these events are emitted. So they have that support. Are there any more questions?
I've got one. It seems to me that events are something ephemeral. And a database, a good database, which has been properly curated, I can reconstruct all the events. In other words, with your salad, right, if you add a salad and take it out, if I use like a double counting entry type of system, I can see I would put a plus to go in and a minus of the salad out. So I can infer the events. Why would I want to focus so much on the events?
So the thing is...
I can see that you want to decouple systems using an event-driven architecture, but it seems like you're just duplicating data, which is ephemeral.
All right. It's a good question, but you know the reason why the accountants don't use eraser. They have a ledger. Does accountant delete and plus and minus? No. People are doing this stuff from long time. Only we in IT are realizing it. So to answer your question on a more technical level, the thing is, events are immutable. And when you have an immutable system, you can recreate everything. So when you do plus and minus, yes, that time you know this thing happened. But if, let's say, you have all the events from beginning till end of mine, you can interpret that info in future as you want. Maybe you can feed it to machine learning, maybe you can give it to AI, or maybe your business want to enter in a new market and they want to do some risk analysis. One more thing which you need to do is audit log. In various domains, you have to make sure that things are audited properly. So in our domain, because of compliance, we have to do proper auditing. And there are many bunch of scenarios which I can say. Does it answer your question? All right. Any more questions? All right, so there is one.
You mentioned that the relational database is a no-go, and this is out of your experience. Could you put more information about it?
All right.
What went wrong?
I can say what went right was that we started very fast because everyone knew relational database. But what went wrong is a long story. Actually, I was thinking to do a talk on pitfalls of CQRS, and that database was one of that. So the thing what happens is relational databases are quite good, but when you are storing the events, basing on if you use XML or JSON, first of all, the payload can become bigger or smaller, but that system tends to produce lots and lots and lots of events. It means your database grows a lot in size. And if you want to replay all those events, let's say, you know, I'm afraid the throughput of relational database is not there yet because they are meant to do something different, and we are using them for something which provide fast write access and fast read access. And usually you don't want to maintain even indexes inside. And when we reach at the scale of, you know, billions of events, we started seeing the pain of relational database. So you need a dedicated DBA who can maintain the database and make sure that everything up and running, and even a small update in the event store. Let's say you are updating a version from X to Y, only that DBA can do. And the throughput is the real problem. So for me, the replay, because all this becomes useless if you cannot replay your events in a blink of an eye. If I tell you that you can replay something and it will take 2 months, you already lost your business case. So you need to have something which replay as fast as possible. So replay time was the big problem. So this brings me to the end of my questions and answers. If you have more, I'm going to be around. So thank you very much for attending my talk.